Hi everyone. Yesterday we learned how to graph linear inequalities, and the nice thing yesterday was that y was always by itself. So y had already been isolated for us. In the examples that we do today, that's actually not the case. We need to do some work first to rearrange our inequality before we can graph it. So we'll just do a couple examples of these, and then there is one new concept. So let's start, we'll just do 1 and 2. So let's start with number 1. If I want to get y by itself, the first thing I have to do is move x over to the other side. And I'm going to do that by subtracting x from both sides. So now this is gone. I have to be very careful here to remember to bring down my negative 2y. My inequality symbol is the same. Now I have a negative x, and I could put plus 0, but since that's just 0, I'm just not going to bring that down. So now what I need to do to get y by itself is to divide by a negative 2. So that's going to cancel. Now I have y by itself. Because I divided by a negative, I'm going to make myself a note to flip there. So my inequality becomes less than or equal to. Now, really what I had here was a negative 1x. So a negative 1 over negative 2, if you use your fraction key, your alpha y equals, and type that in, it just simplifies to 1 over 2, and then I have x. So now I've completed step 1. I've got y by itself. So now I'm going to identify from that equation my slope and my y-intercept. My slope is 1 over 2. My b is that plus 0, really, that would have been there, so my b is 0. So now I'm going to plot my y-intercept at 0. I'm going to find a second point using my slope, which is 1 over 2. So up 1, over to the right 2. So now I've got to decide about dashed and dotted lines and where to shade. So if I look at my inequality symbol, I have a less than or equal to. So that tells me I need a solid line. So when I connect these 2 points, I'm going to use a solid line like that. And now I need to decide where to shade. Since this is less than or equal to, that means I'm going to shade below the line. So everything underneath this line is going to get shaded in. Now, I always like to test a point to make sure I did this right. Obviously, in this case, 0, 0 is on the line, so that's not a great one. So, I don't know, I'm going to check maybe this point here, which is 2, 0. So my original inequality was x minus 2y is greater than or equal to 0. I know this is my x and my y. So when I go to substitute, x is 2. Then I have minus 2. In parentheses, I'm going to substitute my y, which is 0. And then I'm checking, is that greater than or equal to 0? Let's see, when I do that, 2 times 0 is 0, so 2 minus 0 is 2, is greater than or equal to 0, and that checks out. So it means I shaded correctly all these points underneath. So remember, this work right here is really just your check step, which I highly recommend. It's a great way to know if you did the problem right or not before you turn in your test. All right, we'll work through another one. We'll do number 2. Again, my goal is to get y by itself. So I need to get rid of this x by moving it over. So then I'm going to bring down a 4y. My inequality symbol stays the same. I have a negative x and then a minus 8. So now I'm going to divide by 4 everywhere. So when I simplify, I get y is less than. This again was a negative 1 in front. So I have negative 1/4 x, and then negative 8 divided by 4 is a negative 2. So now my y is isolated. I'm going to pick out my m and my b. My m in this case is negative 1/4, which tells me I'm going to go down 1 and to the right 4. My b is a negative 2, so I'm going to start with my b value. And then I'm going to use my slope to go down 1 and to the right 4. Now in this case, I have a strictly less than, so I'm going to have a dotted line when I connect my points. I've got my negative slope here. So dotted line. Please make sure it's very clear that that's a dashed or dotted line. And then again, since it's less than, I'm going to shade below. So if I were walking on my line, I'd be up here, so everything below it is down here. Now again, we could test a point. In this case, let's see, 0, -4 is a point in my purple area. My original inequality was x plus 4y is less than -8. So if I substitute my x and my y, I get 0 plus 4 times, in parentheses, I substitute my y, which is -4, and I am checking if that's less than -8. So the 0 is, we can ignore that. So I have positive 4 times -4 is -16, less than -8. Since this is more negative, it is smaller, and we know we shaded correctly. And again, all this work here is just our check so that we can feel good about our answer. All right, then the only extra piece we have to this is doing the same thing, but we need to review a little bit our vertical and horizontal lines. So if you think back, we had this trick, Vux, Hoy. So remember, Vux was our, let me go back to purple, vertical lines that have an undefined slope, and their equations look like x equals. Hoy was our horizontal lines. They have a slope that's 0, and their equations look like y equals a number. So we're going to use that as well as what we've learned so far about graphing linear inequalities to graph these special cases. Now, when I look at number 5, I notice that I just have a y. I don't have an x and a y. So that tells me that this is a Hoy, because I have y here. So now I know that this is going to be a horizontal line. It crosses the y-axis at -3. Now, because I am greater than or equal to, I know I'm going to have a solid line. So at -3, I'm going to put a solid line. Then, because I said it greater than, I'm going to shade above. And I can check. If I pick a point, let's say 0, 0 here, the y-coordinate of my point is 0, which I know is greater than or equal to -3, so I know I've graphed it correctly. Now, I should probably be more careful about making sure this covers in my region here. There we go. All right, we'll just do one more. In number 6 here, you can see I've got x equals, or x is less than, that's my only variable. So that means I have a Vux. So I know I'm going to cross the x-axis at -1. Now, again, since this is strictly less than, now I'm going to have a dotted line. So at -1, I'm going to do a dotted line. Now, in this case, we have strictly less than -1. In this case, above and below don't really make sense. So what I need to do is I really need to think about left and right. So since this is less than, numbers less than -1 are to the left, so I'm going to shade left. So any region over here. And that's how we graph those linear inequalities. So again, I wanted to keep the video a little shorter. We will do a couple examples to start class as usual, and then you'll have time to do some individual practice and ask lots of questions if you've got them. See you tomorrow.